Hello, so this is section 4.2 and today's topic is the unit circle. So the unit circle is a circle centered at the origin. So origin is 0, 0 with a radius of 1. So if we have a graph, this center is our origin, and we have a circle. And we do know that our radius equals to 1. Therefore, this point on the edge must equal to 1, 0. The point above would be 0, 1. The point to the left would be negative 1, 0. And the point below here would be 0, negative 1. So in general, when looking at a function for a circle with radius r, it's x squared plus y squared equals to r squared. Now, if we're thinking about a unit circle, which specifically has r equals to 1, it will be very similar, just with a slight change. So x, still some value of x, plus still some value of y, but instead of r squared, we have 1. So let's look at an example of this here. So what is the radius of the circle x squared plus y squared equals to 7.29? So if you just scroll back up a little bit or looked up at your notes, you'll see that the general function for a circle is x squared plus y squared equals to r squared. Since we're looking for r, we know this part must equal to r squared. So let's isolate that so we can somehow get r on its own. So we do know r squared equals to 7.29. To get r by itself, we need to square root both sides. So we know r equals to, and when you square both sides, you do have plus minus. Now with r, since it's radius, it can't be negative. So therefore, it must equal to positive root 7.29. And let's just write down our answer without the square root here. So this will bring us, so if you, after square rooting it, you'll get r equals to 2.7. And here is your solution. All right, next question. So example, P is a point on a unit circle. Find x if y equals to root 3 over 5. So this time, we're looking at a unit circle. So that is when r equals to 1. And we do know the y value, we're just looking for x. So that general equation is x squared plus y squared equals to, in this case, unit circle, so 1. I'm just going to start filling in the information. X, we still don't know, we're looking for it. But we do know y is root 3 over 5, the whole thing squared equals to 1. Now let's just isolate x by itself. So x squared equals to 1 minus 3 over 25. Okay, and I'll just make this equal sign look more like an equal sign. Now, since it's a fraction, we need common denominators. So x squared equals to 25 minus 325. And we're looking at x squared equals to 22 over 25. Now square root both sides. Remember, when you square both sides, it is a plus minus. The roots are gone. Okay, so let's see. So we have x equals to plus minus. Now we can split this up to root 22, and we have root 25. The root 25 could be simplified down to just 5. And here we are. 2 options there. Okay. Third example here. Ooh, need to make it a little smaller. So find the y coordinate of the point P if x equals to 0.7 and the angle in standard position is in quadrant 4 in a unit circle. So we need to find the y coordinate. So it is still a unit circle, so r equals to 1. So therefore, this time we know x, so x squared plus y squared equals to 1 because of the unit circle. So we have 0.7 squared plus y squared equals to 1. So we're just going to move things over. Let's isolate y by itself. So, oops, y squared equals to 1 minus 0.7 squared. So from here we know y equals squared equals to, let's see, so it's 0.51. We want to get y by itself, so it's going to be plus minus here. So we know y equals to plus minus root 0.51. So let's just do a quick sketch here. So we have our unit circle. And right now we're looking at the point x equals to 0.7. So remember the unit circle here is basically 1, 0. So 0.7 must be somewhere like here. Now we're trying to find the points on the circle with that x value. So if you go up or below, you're going to find a point that is on the unit circle. And we need to figure out that y value. But we've already calculated what the y value with is. So we do know that since we're looking at quadrant 4, we are looking at the quadrant down here, so we can basically ignore that point in quadrant 1 because that's not what the question is looking for. So therefore, this point right here, we do know x is 0.7, and our y value, since we're in the 4th quadrant, must be negative, so it's going to be negative root 0.51. So just to make it clear what our answer is, so y equals to negative root 0.51. Okay, there we go. All right, so this next part is kind of like what we looked in PreCalc 11, but a little different now. And we're looking at special triangles. So I know this is not a triangle, but I'm just going to sketch down that unit circle. So from our unit circle, we do know that we're looking at a radius of 1. And if you have a radius of 1 and you just kind of draw a straight line down, well, you can create these special triangles that we looked at back in PreCalc 11. So there's 2 different triangles. One is kind of flatter and a little longer, something like that. And then there's one that looks a bit more equal from both, with 2 of the angles. So let's just write down what those angles are. If you remember, you don't have to, you could just pause this and write it down. If you don't remember, just follow along. So with this bigger triangle on the right, it's kind of the same. We do know that we're looking at the 45, 45, 90. So let's just write that, the 45, 45, 90 triangle. Now let's write that also in radians since that's what we learned. So this would be pi over 4. This would also be pi over 4. And the 90 would just be pi over 2. And for the other triangle, we're looking at a 30, 60, 90. So again, here's our 90. It's just the box, 90. So we have our 30 on this side and 60 up there and 90. And again, with radians, this would be pi over 6 and this would be pi over 3. Okay, now we're just going to fill in the knowledge of our sides. Now, since these 2 triangles are part of the unit circle, like how we've drawn here, so we know the hypotenuse is the same as the radius, so it's 1. So that means this is 1 and that is 1. From there, you're just going to apply kind of that knowledge that you got from last time or whenever you took PreCalc 11, And you should be able to deduce that this side is pi 2, or sorry, not pi, root 2 over 2. Since these have 2 of the same angle, therefore you're going to have 2 of the same kind of side. With the 30, 60, 90, you're going to have half on this side and root 3 over 2 down there. So with these two triangles, it's a little different, but very similar to what was covered before. You will need to use these. These will come in very handy. So I suggest you to memorize these. Okay, so do memorize what angles they are and what the length of the sides may be. Next question. So find the point on the unit circle given P 7 pi over 6 is in standard position. So with these questions, it's always a good idea to sketch it out. So we have our unit circle kind of here. And right now we're looking at 7 pi over 6 in standard position. So just to label the sides of our graph here, so we're starting at 0 here. Since we're looking at 7 pi over 6, this is radians. So let's maintain it radians. So up here, we basically have pi over 2. Here is pi and 3 pi over 2. So 7 pi over 6, that is going to be, let's just change our sides to have the same denominator. So instead of pi over 2, this is basically 3 pi over 6. And here we basically have 9 pi over 6. And on the pi side here, we're basically looking at 6 pi over 6. Now, right now we have 7 pi over 6, so we're going to be in this third quadrant. And I'm just going to draw a straight line down. And if you put in that terminal arm, you'll notice that you can actually make a right triangle. Now, I'm going to just zoom in on that triangle here on this side. Since 180 degrees brings us here and we're a little over, we do know that this angle right here is in fact pi over 6. And since this is 90, then this other angle must be pi over 3. So now we're just going to fill in with the information that we know. This is a unit circle, so we know this side is 1. Therefore, this must be 1 over 2, and this top part must be root 3 over 2. So now, applying this triangle back to our little triangle in the unit circle, we know this part is basically root 3 over 2, and this y section is basically half. And since we're in quadrant 3, we do know we're going in the negative and negative here. Therefore, the point that we're looking at is negative root 3 over 2, negative half. This is that point. All right, next question. So find a theta such that P negative root 2 over 2 and root 2 over 2. So finding an angle with that point. So again, since we're looking at negative root 2 over 2, so it's negative x positive y, would be somewhere in quadrant 2. So looking at our unit circle actually, we do know if we have negative root 2 over 2 and root 2 over 2, it's gonna be like here. And you should be able to recognize these two sides. So basically our first point is our x, which is that length there. And here is basically our y, that's a y, which is this point up and down. And when we have root 2 over 2 as a side, we're looking at our 45, 45, 90 triangle. So let's just write that down. So basically here's our 45 and 45, okay? So in this particular case, starting from our initial arm, this is our standard position angle right here. And we do know this angle right here must be 45, just from our knowledge of this triangle. So standard position will just be 180 minus 45, which will be 135. Now, if you were thinking in radians instead of 180, that's pi minus pi over 4, and you have a difference of 3 pi over 4. So these are two possible answers depending on which units you're referring to. All right, reference angle. This is something that you also have looked at before in Pre-Calc 11. So with reference angle, usually it's represented by theta and then a letter R to represent reference angle. So just going to draw on the quadrants just for your reference. So reference angle for your reference. So terminal arms can be in all quadrants. Okay. So here are basically 4 terminal, oh goodness. These are basically 4 terminal arms. And the reference angle is an acute angle. Acute angle is any angle that is smaller than 90 degrees between terminal arm and the x-axis. So this line here is the x-axis, okay? And the reference angle would be, for example, here would be a possible reference angle. Here would be a reference angle. Here would be a reference angle in the 3rd quadrant, and in the 4th quadrant, it'll be here. So please note that this one that I'm drawing here is not a reference angle. I don't know why students really like that one, but no, it has to be with the x-axis, not the y-axis. All right, last question here. So let's find the reference angle if the standard position angle is 13 pi over 16. So let's just, again, just draw it out. So 13 pi over 16. So we are looking at radians, so keep it in radians. So here is 0, up here is pi over 2, here is pi, and 3 pi over 2. Now, since we're looking at denominator 16, let's change up our sides to 16, and maybe it'll give us a better view of where we should put it. So 12 to 16, we'll have to multiply top and bottom by 8. So 8 pi over 16. Here is basically 16 pi over 16. And 3 pi over 2 would be 24 pi over 16. Okay. Now, since we're looking at 13 pi over 16, that's going to be in the 2nd quadrant because it's between 8 pi over 16 and between 16 pi over 16. So we'll say it's somewhere like here. Ooh. And this part right here is 13 pi over 16. And here, this part is basically our reference angle. So what is our reference angle? So our reference angle in this case is pi subtract our standard position, which is 13 pi over 16. Now, since we're subtracting, we need to have the same denominator. So that's equal to 16 pi over 16 subtract 3 pi over 16, which is 3 pi over 16. So our reference angle is indeed 3 pi over 16. And that is all I have for you for this section.